let's go over scientific notation review. Number 1. So 5.2 times 10 to the third. So to take it out of scientific notation, so it says express each of the following in standard form. So the exponent right here tells me I need to move my decimal 3 spots. But which way? Well, 10 to the third is kind of a big number. It's 10 times 10 times 10. That's a large number. So we're going to make it bigger. If I moved my decimal point this way, 3 spots, I would end up with this really small number, which doesn't make any sense. So that tells me to move it the other way. So 1, 2, 3, and fill in with zeros. So my answer is 5,200. And so that's one way to logically think of it. And to help you, if you can't remember which way to do it, think of it logically. Let's look at number 2. 9.65 times 10 to the negative fourth. So we know we're going to take this out of scientific notation, but which way? Well, we know that negative 4 is a small number. So let's make 9.68 smaller. And we're going to do that by moving the decimal 1, 2, 3, 4. And we fill in with zeros. So our answer is 0.000965. Number 3, 8.5 times 10 to the negative 7. Negative 2, sorry. And negative 2 is a small number. So let's make 8.5 smaller. 1, 2, add a 0. So my answer is 0.85. And 4, 2.71 times 10 to the fourth. 10 to the fourth is a big number. It's 10 times 10 times 10 times 10. So we've got to make this other number bigger. 1, 2, 3, 4. So my answer is 27100. All right, so now we're going to learn how to make things in scientific notation. So my problem here is 78,000. Let me start on a new page here, 78,000. So let's talk a little bit about something you can memorize. So with scientific notation, when you move the decimal point, when you move it this way, you're going to add to the exponent. When you move it to the right, you're going to subtract. And however many places you move the decimal, that's what you add or subtract. So if they don't give you a decimal, it's always at the end. Now for scientific notation, it's always 1 digit, then the decimal, then whatever else is there. And for us, we moved it 1, 2, 3, 4 places, so it's 10 to the fourth. And it's going to be a positive 4 because we went to the left. And when we go to the left, we're going to add, so it's a positive 4. Number 6, we want to put this number in scientific notation. So now we're going to move it to the proper. So we want 1 digit and then a decimal. So 1, 2, 3, 4. So here's our 1 digit, then the decimal. So it's going to be 5.3. This time we went this way, so we want to have a negative number. And we went 4 places, so it's 5.3 times 10 to the negative fourth. Number 7, 250. Here's a decimal, 1, 2. Our answer is 2.5 times 10 to the second because we went that way. Number 8. So this one we need to count those zeros. And there are 6 of them. and then a 1 and a 6. So let's go ahead and move our decimal 1, 2, 3, 4, 5, 6, 7. So we moved it 7 times, so it's 10 to the 7th. And it is not a 7th, it is a negative 7th because we went this way, so we have to have a subtraction. Negative 7. Number 9. Now we're going to add, and adding and subtracting are not fun. So multiplying and dividing are actually better with scientific notation. Adding is a pain. It's not that hard, it's just you have to do more steps. So the thing with adding and subtracting in scientific notation is that you have to change both of the exponents to be the same. And so I need to either change this to a 3 or this to a 5. So it doesn't matter. I'm going to choose a 5. So we can keep this one at a 5, and we need to change this to a 5. So 3, and we're going to change it to a 5. And there's a difference of 2. 5 minus 3 is 2. We're going to find the difference. That means that 2 is the number of decimal places to move the decimal point. So I need to move it 2 places. But which way do I need to move it? Well, I'm actually adding 2 to the exponent. So when I add to the exponent, I need to move it to the left. So here's my decimal, 1, 2, and I'm going to fill it in. So this number turns into 0.03 times 10 to the 5th. That's an equivalent number. So now when I add 2 times 10 to the 5th plus 0.03 times 10 to the 5th, my answer, I add this number and this number together to 0.03, and 10 to the 5th just stays at 10 to the 5th. And so that's my answer to number 9. Let's try it again. Number 10, 3.27 times 10 to the 4th plus 9.8 times 10 to the 3rd. So I've got to change them to be both the same exponent, and I think I'll change them to be 10 to the 4th. So I've got to change this 10 to the 3rd to 10 to the 4th. And that's a difference of 1, so I need to move the decimal 1 place. Since I'm adding 1, so 3 plus 1 gives me 4, I need to move the decimal place once. And I'm adding to it, so I'm going to move it to the left. So this number is now this. And now I can go ahead and add. So I need to kind of off to the side do some scratch math here. So I have 4.25, so my answer is 4.25 times 10 to the 4th. And so that's the answer to 11. Sorry, that was the answer to 10. Now we're on 11. So number 11 is 9.06 times 10 to the 5th. And I need to change this one. This one's going to be more challenging to change. So I need to change it from a -2 to a 5. So what's the difference there? It's actually a difference of 7. From a -2 to a 5 is not 3. It's the difference between those two is 7. So I need to move the decimal 7 places. We are adding 7 to get 5. So I need to move this back 7 places. 1, 2, 3, 4, 5, 6, 7. So my answer is, or my new number is 1, 2, 3, 4, 5, 6, and 3 and a 1 times 10 to the 5th. And so that's what this new number is. So now I can add them together. And when I add 9.06 with this big long number, I get 9.0600031 times 10 to the 5th. Kind of an ugly number right there. All right. Subtracting is along the same lines. You've got to change the exponent. So the first, number 12, is 9 times 10 to the 11th minus 7 times 10 to the 10th. Let's go ahead and change the 7 here. Well, first we have 9 times 10 to the 11th, and we're going to subtract. And we're going to make it to the 11th, so let's change this to 0.7 times 10 to the 11th. It was 7 times 10 to the 10th. Now we're going to change it to 0.7 times 10 to the 11th. So now we can just do 9 minus 0.7, so 9.0 minus 0.7. And we're going to get 8.3. And the 10 to the 11th just stays as is. And there's our answer. 13. 2.8 times 10 to the 4th. Negative 4th, let's say negative, minus 1 times 10 to the negative 2nd. And so let's go ahead and change that negative. Let's change the first one this time. Let's change the 2.8 times 10 to the negative 4th to a negative 2. So going from 4 to 2 is a difference of 2. So I need to move the decimal 2 places. And I'm actually adding. So negative 4 plus 2 gives me a negative 2. So I'm adding 2, which means I need to move the decimal that way. So I need to move it 1, 2. So 0.028 times 10 to the negative 2nd. And that's the same equivalent number. 1 times 10 to the negative 2nd. So now I need to subtract. And I can do my subtraction off to the side. And when I do this subtraction off to the side, this is actually a negative number, and I'm finding the difference here. My number ends up being a negative 0.972 times 10 to the negative 2. And again, review how to subtract with decimals if you don't remember how to do that. This is not proper scientific notation. Proper scientific notation wants the decimal after one whole number. So I need to move this one place to make it proper. And since I moved it this way, I need to subtract one from the exponent. So minus 2 minus 1, or minus 2 minus 1, gives you 9.72 times 10 to the 3rd. Multiplying and dividing is actually easier than adding and subtracting. So to do this, we have 2 times 10 to the negative 3 times 9 times 10 to the negative 3. So what you actually do with this is you multiply 9 and 2, so you get 18, and you actually add the exponent. So negative 3 plus a negative 3. Negative 3 plus a negative 3 gives you a negative 6, like that. So that's your answer, but to put it in proper scientific notation, we want to move the decimal once. So So we get 1.8 times 10 to the negative 5. 16. Let's try this again for more practice. All right, so we're going to multiply 2.8 times 4. And my answer is 11.2. And I'm going to add my exponents. So negative 6 plus a negative 5 gives me a negative 11. Let's make sure it's in proper notation. So I'm going to move this over once, 1.12. And since I moved it to the left, I'm going to add 1 to the exponent. So when I add 1 to a negative 11, it makes it a negative 10. All right, going on to number 17. One more practice with multiplying. 7.1 times 10 to the negative 5 times 6 times 10 to the negative 6. So 7.1 times 6 is 42.6. And then we're going to add negative 5 plus a negative 6, and that gives me a negative 11. Let's move the decimal one place to make it proper. And that's our answer to 17. 18. So 18 is dividing, and dividing is similar. Divided by 2 times 10 to the first. So we're going to take 7.1, divide it by 2. And so I can just do my long division right here. Here's my decimal. Make sure I don't forget that. So my answer is 3.55. And we're going to take, now with dividing, we're going to subtract 6 minus 1. So my answer is 3.5 times 10 to the 5th. Number 19. So here we're going to divide again. 4 times 10 to the 4th, divided by 2 times 10 to the negative 4th. And so don't be fooled by the 4 and the negative 4. If you added them together, it would be 0, but you're not. You're subtracting it. So it's 4 minus negative 4. And these two negative 4's cancel out, and so our answer is 8. So 4 divided by 2 is 2, and this would be times 10 to the 8th. Number 20. 5.4 times 10 to the negative first divided by 10 times 10 to the first. And so my negative 1 minus 1 is actually going to be a negative 2. So my exponent is going to be 10 to the negative 2. And we're going to divide. 10 goes into 5.4. And here's our decimal. So it goes in 5 times. I'm going to subtract. And then I'm going to add a 0 and bring it down. And it goes in evenly at 4. So my answer is 0.54 times 10 to the negative second. But I need to now put this in proper scientific notation. So I'm going to move this once to 5.4. And then my exponent, since I moved this way, I'm going to subtract from the exponent. So I'm going to subtract 1, and it's going to be a negative 3. So negative 2 plus a negative 1 gives a negative 3. Now we're on to some word problems. A farmer cultivates 2.3 times 10 to the fourth acres of land and leaves 5.3 times 10 to the third acres untouched. How many acres does he or she own? So it's just a basic addition problem. We want the total amount owned. So I've got to change one of these to a different exponent. So I think I'm going to change the 10 to the third to a 10 to the fourth. So I want this to be 10 to the fourth. So in order to do that, I added 1 to the exponent, so I need to move my decimal one place to the left. So it's going to end up being 0.5 10 to the fourth. So that's my new problem. And now when I add these together, I'm going to have 2.3 plus 0.53. And so my answer is 2.83 times 10 to the fourth. Number 22. Farmers in a certain state lose 2.3 times 10 to the second kilograms of topsoil per year on average. And there are 4.5 times 10 to the third farmers in this state. How much topsoil is lost in this state annually? And so this is kilograms. And so we're going to go ahead and multiply. So to multiply, I'm going to take 2.3 times 4.5. And I have, let's see, 1 and 2. So 1, 2. So my answer is 10.35 times 10 to the, and remember when you multiply, you add 2 plus 3 to the fifth. But it's not in proper scientific notation. I've got to move it once to make it 1.035 times 10 to the 6. And the answer comes out as kilograms. 23. A new construction site releases dust particles that measure 2 microns, 2 times 10 to the negative 6 meters. 600,000 particles are released each hour. What is the total length of the particles released in an hour, in a day, and in a year? Okay, so we have this many particles. That's the measurement of the size of the particles, and it's saying 600,000. So 600,000, if I put this into scientific notation, I'm going to go 1, 2, 3, 4, 5. So it's going to be 6 times 10 to the fifth. And this is particles per hour. And so now my particles cancel, and I'm going to multiply 2 times 6, which is 12, and I'm going to add the exponents. Negative 6 plus 5 gives me 10 to the negative first, and this is meters per hour. And if I'm going to take this out of scientific notation, if I make it into proper scientific notation, I'm going to move the decimal one place to get 1.2. And then I'm going to add 1 to my exponent, which actually makes it 0. So my answer, to the 0 you can just drop, is 1.2 meters per hour. That's the first part. Now we're going to take the meters per hour, and we're going to figure out how many days how many meters per day. So now it's 24 hours per day. And when you do 1.2 times 24, and you can do that over to the side, you're going to get 28.8 meters per day, because our hours cancel, which is in proper scientific notation 2.88 times 10 to the first meters per day. And now the next part is we have, I'm just going to actually for this part I'm going to go ahead and use this instead of scientific notation. And we have 365 days per year. And off to the side, go ahead and do this math problem. And when you're done, you will get the answer is 10,512 meters per year. And in proper scientific notation, it's 1.0512 meters per, oh, forgot my 10 to the 4th, times 10 to the 4th meters per year. All right, next one, the density of calcium carbonate in coral reefs is 2 times 10 to the 3rd kilograms per meter cubed. If the calcium carbonate in the reef weighs 4 times 10 to the 8th kilogram, what's the volume? This was on an AP test one year on an FRQ, and it expects you to remember, because you've been learning this since junior high, that density is mass over volume. And so it gives us our density. It says that the density is 2 times 10 to the 3rd kilograms per meters cubed. And we have our mass as 4 times 10 to the 8th kilograms. We want to solve for V, for volume. So we can actually, in this type of problem, we can actually cross multiply. And so our V switches up here, and our 2 times 10 to the 3rd switches down here. And our kilograms are going to cancel, and we're going to be left with meters cubed, which is great because that's volume. And when we divide, 4 divided by 2 is 2. And remember, in scientific notation, when you divide, you subtract. So this is going to be times 10 to the 5th meters cubed. So the problem ended up not being very hard, as long as you remember what density is and how to do scientific notation.